Okay, so in this problem we have a bullet having a mass of little m which strikes a stationary pendulum at a distance h from the pivot point O with the speed of VB1. We're told the pendulum has a mass of capital M and has a radius of gyration about the pivot point O of k0. We're also told that the bullet embeds itself immediately within the pendulum upon impact. Given this information, we're asked to determine the angular speed of impact, the angular speed of the pendulum immediately after the impact occurs. Okay, so the thing that we're going to note here is we want an angular speed after an impact event. That's going to be a key indicator to us that we're going to want to use angular momentum methods. And so to this end, what I want to do is I want to start by drawing a free body diagram for my system. In this case, making the system as large as possible, inclusive of both the bullet and the rod. So if I do that, I'm going to note that the only forces I'm going to create here is the net weight force, which will be m plus m times g. And we'll have here reactions at point O, which I can call OX and OY. Now the key takeaway here is that we have, in this case, that the summation of moments about point O is going to equal 0. And that means that angular momentum will be conserved in the system pre and post impact. So I can say h about O at state 1 is going to equal h about O at state 2. Now immediately prior to the impact, we have only the bullet moving, and so what I can do is I can treat this as a particle part of the problem. So I can define my x and y axes like so, and then note this is going to be r1 cross m times v1. And if I do a little substitution here, my position vector is going to be minus h in the j, and I'm going to cross that with the mass times the initial velocity, which will be minus vb1 in the I direction. So if I take j cross I, I'm going to get minus k. And so I'm going to have minus m times h times VB1 in the k. Now post-impact, we're going to have kind of a compound object here in pure rotation. So I'll have an angular momentum of I about O times omega 2 in the k direction. And I really just need to find I about O. So in this case, I about O is going to equal I about O of the pendulum plus I about O of the bullet. We know the pendulum. In this case, we're given, I believe, a radius gyration about point O, so this is simply going to be m times k0 squared. The bullet can be treated as a particle, which means that it will have no moment of inertia about itself, but we will have to account for the parallel axis theorem component required to move A back up to point O. So here we're going to have m plus m times h squared. So we can take this result for the mass moment of inertia, plug it back in here for HO2, and then equate HO1 and HO2 and get our net result, which is omega 2, the angular velocity post-impact, will equal the scalar component of omega 2 in the k direction. From here on out, it's just a relatively straightforward exercise in substitution, and one I know you got well under control. So I'll simply bid you adieu and the best of luck.